Hey guys, welcome to a short instructional video on balancing Jeti servos. So this particular video is based on the Composite ARF F100 setup, which is right here. We've got two servos that are operating this horizontal stab, and I'm going to show you guys how to balance this out and how to make it work with very low amperage draw. So stay tuned for that. Thanks for watching, like and subscribe, and hopefully you find this video useful. So as we're doing this, of course, this is all based on Jeti. So we have a central box. We've got both servos plugged into our central box. Our servo layout that I always use is if aileron is 1 and 2, aileron 1 is always left, aileron 2 is always right. Elevator 1 is always left, so it's this one right here because as you're sitting in the plane, this is our left elevator. 4 is our right elevator. So we've got that set up, we've got a battery in there. We're going to turn our radio on, get it set to the correct model. All right, so we're on the correct model. Now we're going to turn the central box on. We're going to pull our bind plug from the central box. And both of our servos are sitting at the neutral location. Now the neutral location is going to be pretty balanced. We've got the servos centered and everything. So this isn't the concern right there. Now one of the things we can do with the central boxes and the Jeti system is we can get our timer or time up here to be amps. So I'll show you guys how to do that. The important thing when you're doing this, in this specific scenario, is you're only using one battery because it's going to give you a more accurate setup than using two batteries. Okay, so first thing we need to do, if you don't already have this set up, by default this won't pop up. So we want to change that to amps. So we're going to go menu, we're going to go down to timer sensors, we're going to go to main screen. So this is the stuff that's displayed on the main screen. So we come down to telemetry displayed at clock panel and we pick amps from 1, okay? If you had two batteries in here, it's not going to give you an accurate representation because the central box is also pulling power from number 2, but you can only look at one at a time. So we set that to 1 with the A, which is amps, not voltage, amps. So then when we plug our battery in, we're plugging into battery number 1. So we've got that set up already. And you can see right now with this system completely at neutral, not doing anything, the servo being powered on, it's not pulling anything. The receiver and everything is pulling 0.17 amps. So if I take this surface and you guys watch the amp screen while I move it, that's going to go up. And leave it at neutral and it's going to go back down. Okay, so first thing I'm looking at here is our servos are going the wrong way. So if I go up elevator, it's going incorrect. So first thing we need to do is we need to change our servo direction to be correct. So we're going to go menu, model, servo setup, and this is elevator 3 and 4. So we'll do one at a time. Once we do this, it's super important you don't touch the stick because one servo is going one way, one is going the other way. So we'll use our arrows, go to the next one, and reverse. You can hear the buzz go away. And now if I do up elevator, our servos are moving the correct direction and we're at the correct neutral. So what we're going to do is we're going to use our left servo as our primary and we're going to use our right servo as the one we're matching the left servo to. So elevator 1 is our primary, we won't touch that at all. Elevator 2, which is port 4, on the central box is our servo that we're going to adjust. Okay, so what we do is we go down to, we're on the correct surface, so elevator 2. We're going to come down to our servo balancer. Now when you're doing the servo balancer, what you're doing is you're looking at the amps on your radio. So if we move this stick through the range here and we stop at the first button right there, you'll see that our amps are 0.5, which actually is really good. Like if you're under an amp, you're doing pretty stinking good. We're going to go a little bit further. Now we're getting a little higher. And now as we go further, the servos start to balance out. We're below 1 amp. So basically going with up elevator, that second dot has a little bit of an imbalance. Now we'll go the other direction. First dot, big imbalance. Second dot, bigger imbalance. Third dot, big imbalance. So forward elevator, we got a very significant imbalance. So we take auto off, and as you push the button, it's going to go through the different locations on the servo travel. So what we can do is, we know this direction is very bad, so forward elevator. So you can go like this to that first dot. You hold down or push the function 4 button, which is servo lock. Now I can let go of the stick, and I can take this, get it on that dot, and remember, we're only adjusting the first servo. Our amps are going up, so we're going the wrong way. There we go. Boom. So now at that first point, those servos are perfectly balanced. Now if we take this off, it's going to go back to neutral. Our servos are perfectly balanced at neutral. So again, if we move our stick through here, very low amperage, which is good. So now we're going to go to our next point. And the points are just somewhere to actually reference from. So there's our next point. Push our scroll wheel again, and I'm just guessing that we have to go up. That's probably correct. And just going until we don't hear any buzz. Now it looks like you're adding a ton of movement here, but you're not. You're only adding 3.4%. But right now, when we use forward elevator and go to this point, the servos aren't going to be fighting against each other. So that is forward, and now we're going to go to our next one. So that dot there, I'm going to take off servo lock, and we're going to go forward to point 3, lock it, and again we're probably going this direction. You see our amperage start to come down. Amperage is going back up. If we go the other direction, amperage goes way up. So we are the correct way. We just want to pick the point where we get the lowest amperage. So we start to go up again, so I'm going to go back the other direction. So about there is our lowest amperage. Below 1 amps is good. Unlock that. Now I haven't adjusted my limits here yet, so I don't know. We might be getting into that limit of the actual surface movement there. That's why it's buzzing so much. But at least at this point we're as balanced as possible. Now we'll go the other direction. So we'll go to this point here. We'll lock our servo in, push our scroll wheel until we get to this point. Now we're perfectly balanced. The servos aren't buzzing. So we'll unlock the servo, go to our next point, lock it, push our scroll wheel, and there's some work that we can do here. Now I'm going to guess, there we go. I was guessing that we have to go the other direction. So if I go a couple points there, minus 0.6%, 0 draw. And that's because at neutral, that's our amperage of the radio or receiver being on. So we'll unlock this. Go to our next point, lock it. Now the point of locking this on a point is just so you have somewhere to move. You can go in between, but the points here just give you some reference point. And there we're good. So we just needed a little tiny bit on that one right there. Now those differences come from servos, they come from rod lengths, fastener differences, lots of that stuff. And that's the point of balancing this. Now, you may be able to get away with not balancing these servos in the Jeti radio. The problem is every time you are pushing forward elevator, you're drawing, and that's not even air holding or fighting against the surface. We were drawing 3 to 4 amps. So when guys talk about their servos use way too much power, in a situation like this, make sure you adjust your servos because they could be fighting each other. On a standard surface where you've got one servo, obviously different story. So now, if we use our stick and go through this motion, unlock it, we should see basically kind of below 1 amp the entire time. Awesome. Go the other direction. Below 1 amp the entire time. Beautiful. So those servos are perfectly matched now. I didn't want to reduce the travel at this point because I wanted to make sure we were able to access all of our servo travel. All right, so we've got our limits adjusted here. So what we're doing is we're doing up elevator 48, down elevator 42. So what I did was we went into dual rates, which is in fine tuning, dual rates. Right now it's global, so we don't have different flight modes set up there. And we dropped our elevator to 60%, 30% expo. So now, if we use our stick and go through this motion, unlock it, we should see basically kind of below 1 amp the entire time. Awesome. Go the other direction. Below 1 amp the entire time. Beautiful. So those servos are perfectly matched now. I didn't want to reduce the travel at this point because I wanted to make sure we were able to access all of our servo travel. So that got us kind of in the range, stopped us from hitting the stops built into the fuselage. Then what I did was we need different travels for up and down, right? Up we need 48, down we need 42, so less forward or down elevator. So what I did was I went into our model, servo setup, and we adjusted the hard or max positive limits on both servos. So the reason I did it there is because I don't want any mixes or anything to have the possibility of going too far on this aircraft. So if you go too far, this carbon arm that goes in between these two surfaces is going to absolutely destroy this fuselage. So setting the max positives and negatives on an aircraft like this is extremely important. That's why I did it here. We kept the servo travel at 100%, which is fine. And from here, after the first flight, if somebody thinks, well, in regular flying, we need a little bit less travel in regular flying mode, then regular flying mode, you drop the dual rate down to 50%. Takeoff and landing, you might keep it at 60%. If this goes higher than that, we're not going to be able to get any more travel out of this surface because our max limits are our absolute limits. So as an example, I'm going to go into my elevator dual rate. We are going to go here and I'm going to increase this number. So you can see here, if we go up elevator, it stops. It's at the physical stop. It's at our travel amount. And I'm going to take that number and I'm going to shift it up to 100%, and we won't get any more travel because it's not available because our max numbers are limited. Now if we go the opposite direction and go negative, that starts to limit our travel. There we go. All right guys, and hopefully you found that useful on how to balance a pair of servos in a Jeti radio system using a central box. That amperage feature that we talked about during this video isn't only for this scenario, it's for an entire setup on a plane as well too. So it's very valuable, very useful, but if you do use a Jeti system and you do have two servos paired up, I encourage you to make sure you go through this step because it's very valuable and ensures your equipment is operating as best as possible. Thanks guys for watching. Thank you channel members for your support. And if you're watching this and you're wondering what the heck is channel membership, there's some links down below to what channel membership is. Check it out. It's a paid thing, but our channel members get to see our videos early. So thanks guys for watching and we'll see you in the next video.